What is up, Algebra 2? This is lesson 4.10, and we're trying to write equations of quadratic functions given certain information. So now I'm not trying to graph them or find stuff out about them. Now I am trying to write an equation given information about the parabola. So before we get started with that, there are three equations you need to remember. First of all, this vertex form is very helpful whenever we're given a vertex. Notice the vertex is the point HK, and then you also need this variable out here, and it has an x and a y in it. Intercept form is x minus p, x minus q, where p and q are intercepts, and then notice there's also that coefficient out there, a. And then there's a standard form, which is ax squared plus bx plus c. And so we're going to be using each one of these in different examples. Alright, so first of all, we're trying to write the equation of a parabola that has a vertex of this and passes through this point. Okay, so we know that it has that as a vertex and it passes through a point. So since it gave us the vertex, that should instantly trigger my mind that I want to use the vertex form. And so here's the general idea here of the vertex form. Y is equal to a times x minus h squared plus k. So what I did is I plugged these numbers from the vertex into those points in the vertex form, which is that 4 here, notice it says minus h, minus 4, and then plus k, so it's plus a negative 5, which is the same thing as subtracting 5. And then I plugged in the point that it passes through, that 2, negative 1. I plugged in here for the x and the y, which leaves this equation with just one variable right here. So what we're going to do now is we're going to solve for that. We're going to say this is going to be negative 1 is equal to a times a negative 2 squared minus 5. So I'm going to add 5 to both sides, giving me 4 is equal to 4a, because negative 2 times negative 2 gives me that positive 4. So I'm going to divide by 4, and that gives me that a is equal to 1. Now I'm not finished, but that's an important part of my equation. So my equation, I'm going to come back to here, I'm going to use this a, and I'm going to use my vertex to get the equation of the line. So I'm going to end up with y is equal to 1a, I'm plugging a 1 in there, but since it's just 1 I don't have to write it, x minus h, which in this case is 4, squared, plus k, which in this case is going to be a minus 5. And this is the equation, like if I plug that in my graphing calculator, would graph a parabola that has a vertex of 4, negative 5, and that passes through that point. Now, another way they might ask us to do that is if they give us the x-intercepts. So here's an intercept, and oh, here I can also see it passes through a point. And sometimes it just tells us these, sometimes it gives us a picture of it, but either way, we can be able to do that. So now we're going to use the intercept form. And so notice it has this p and the q, which are the intercepts. And it has a couple x's, which is that x we know it passes through, and it has a y. So again, I'm just looking for that a, which is that leading coefficient of this whole thing. So I've plugged in the 6 in here for my two x's, and the 2 over here, that came from right there. The negative 2 I put in here, so minus a minus 2, and then minus a 5 here. So simplifying this down, this is going to give me 2 is equal to a times, so it's going to be 6 plus 2, which gives me 8, times 6 minus 5, which just gives me 1. That makes it fairly simple. This is going to be 8a on the right hand side, which is equal to 2. Dividing by 8 to solve for a, that gives me a is equal to 1/4. So now to write my equation, I'm going to again go back to this, use my intercepts, and use my a. So I'm going to say y is equal to 1/4 x plus 2, because notice it's a minus 2, and then x minus 5. And that is my equation. Now, this is where it starts to get a little bit more complicated, but if we use the tools that we've learned in the past, this becomes not as bad as some people might think it is. This is a parabola that passes through these 3 points. And so what we end up with, we don't know the vertex, we don't know the intercepts, we just know that it passes through these points. So I'm going to go back to my standard form, and notice it has an A, a B, and a C. And because it has an A, B, and a C, that's what we're trying to find out. That's what makes each equation unique. And so I'm going to use these 3 points to come up with 3 equations with 3 variables. Now, I used this first point to come up with this equation. Notice I've just plugged in the -1 for each of my x's and the 5 in for the y. So I was equal to a times -1 squared plus b times -1 plus c. Something similar here for the second point, and something similar here for the third point. So let's see if we can simplify these down to just get like an a, b, and a c. So it's going to give me 5 is equal to a, because -1 times -1 is just 1, minus b plus c. This next one is going to be -1, there's 0 a's, there's 0 b's, and that's c. And the next one's going to be 11. I'm sorry, I should be doing these in different colors. Okay, so notice I have these 3 equations. So there's a couple different options that we can go through here. The first one is going to be to solve this by substitution, which is not going to be too bad, because one of them is actually already solved for. I already know what c is. So if I'm going to solve it by substitution, I know I'm going to be looking for an a, b, and a c, right? I already know what c is. C is at -1. So that works out fairly nicely. So I'm going to go and substitute that value into my other 2 equations to be able to solve this. So I'm going to have 5 is equal to a minus b minus 1. Because again, c is -1. And I just put that in there. And then I have 11 is equal to 4a minus 2b minus 1. So let's see, I'm going to go and solve this first one. I like substitution, so I'm going to use that. I'm going to go through and solve this first one for a. So this is going to give me 6 is equal to a minus b, which means a is going to equal to 6 plus b. That was bringing me to the end of step 1. Step 2 is going to take my other equation. I'm going to go and say 12 is equal to 4 times a. A's other name is this, 6 plus b, minus 2b. So 12 is equal to 24 plus 4b minus 2b. Combining these 2 and subtracting 24. On the right hand side, I end up with 2b. Left hand side, I end up with -12. Dividing by 2. End up with b is equal to, sorry, I'm going by +2, -6. So that's my b. And then step 3, remember, is to plug that in over here. So a is equal to 6 minus 6. So a is equal to 0. So then to plug this into my quadratic, I'm going to plug my a, my b, and my c back into here. So I'm going to end up with y is equal to 0x squared plus, not a plus, minus 6x minus 1, which in this case actually doesn't come out to be a quadratic. It comes out to be y is equal to negative 6x minus 1, which is kind of not as cool as I was hoping for, but you get the basic idea. Another way you could have done that was to use a matrix and gone 1, negative 1, 1, 0, 0, 1, 4, 2, 1, and then that 5, negative 1, and 11. Plug that into your calculator, find the reduced row echelon form, and you would have found those same three answers here that you could have then plugged into here, or I guess here, and gotten the answers. Either way, I think you have the basic idea. Feel free to go back through and look at this again if you need to.